What we're learning in lesson 12.1 is to start with finding the mean, median, and mode and range, all of which are considered measures of central tendency because they measure the middle of the data, and we want to see which one's the best. One thing that we'll be doing quite a bit today for one of our central tendencies is putting the numbers in order from least to greatest. So let's just do that for number 2 to start with. 68 is the smallest number. Then it's 69. Notice how I'm crossing them off as I go through so I don't repeat or miss any. Then it's 71. Then 72. Cross it off. And then I have another 72. Again, I want to count them all. I should have 5 numbers, which I do. So again, we're going to be working with mean, median, mode, and range, 3 of which are measures of central tendency. Measures of central tendencies. So notice how we have a lot of vocabulary words. Central tendency and measures of central tendency are mean, the median, and the mode, all of which measure the middle of the data. Okay, so those 3 measure the middle, whereas range is something other than that. So the mean, another word for mean is the average. And to find that, you add up all of the numbers, so you find the sum. By adding them all up, and then divide that number by how many numbers there were. And we'll practice that. The median is talking about the middle of the data. The middle number when they're listed in order from least to greatest. Each of these would be a really good thing to write down. So again, the mean is the average. You have to add up all of the numbers and then divide by how many there are. And the median is the middle number. So when we list them from least to greatest, we cross them off and find that middle one. The mode, starting with MO, is the number that appears the most. And then the range is figuring out how spread apart our data is. So what we do is we take the largest number, or the biggest number, and subtract the smallest number. So let's do a few of them. As you can see here, we've got different page numbers read in 1 week. The first one is 40, and we'll write it above it, 40, and then we have 45, 48, 50, 50, and 59. The first thing we want to find is the mean. So what we're going to do is we're going to add up all of the numbers to find that sum. When you're adding them up, you want to be really careful that you enter them into your calculator correctly or just add them correctly. In this case, we get 292. So then what we do is we take 292 and divide it by how many numbers we had. We have 1, 2, 3, 4, 5, 6 numbers. So we're going to divide that by 6. And we get 48.6 repeating. So really, we would round that to about 49 pages. That's the mean. The median then is going to be that middle number. So to find the middle number, they have to be written in order from least to greatest. Let's double check that they're in order from least to greatest. They were given to us that way. It's not always the case. And what we do is we cross them off on the outside, one on each side, and make our way to the middle. Notice how for this specific one, we don't have one middle number, we have two middle numbers. So then we need to find the average between those two. So to do that, we have to add them up, add the 48 plus the 50, giving us 98. And then we have to divide that by 2 because there are two numbers left. And when we do that, we get 49. So 49, again, is our number, but it's our median. So it's a different measure of central tendency. Then for the mode, we want the number that shows up or appears the most. So when we look through the numbers, 40 only comes up once. 45 shows up once. 48 is once. 50, you see, shows up 2 different times. And again, it's super helpful to find this when it's written in order from least to greatest. And then 59 only shows up once. So 50 is going to be the mode because it appears the most often. Then when we find the range, we're going to do the greatest value, which is 59. We're going to subtract that smallest number, which is 40. So overall, we get 19 as the range. So our data is spread over 19 different values. We can do that same exact process with decimal numbers. Again, the first thing that I recommend you do is write them in order from least to greatest. When we look here, I see that 2 3/10 is the smallest number, and there are 2 of them. And then our next number is 2 7/10. Then 2 9/10, 3 2/10, and then 4 3/10. And again, we want to make sure that we got them all. 1, 2, 3, 4, 5, 6 numbers. We have 6 again. So now, if we want to find the mean first, we need to add them all up and then divide by how many there are. When I added them all up, I got 17 7/10. Again, you want to be super careful when you type them in, especially with those decimals. Now, because there are 6 numbers, we need to divide that number by 6. And we get 2 95/100. So that's going to be our mean value. Now let's find the median. To find the median, we want to find that middle number. So we're going to use them in order and cross them off. Largest then smallest, then the next smallest, next largest. And we find ourselves with 2 of them. So again, we have to find the average between the 2. So we add them together, 2 7/10 plus 2 9/10, giving us 5 6/10. Then from there, we have to take that 5 6/10 and divide it by 2 because we had 2 numbers left over, and we get 2 8/10. Notice how these 2 measures of central tendency are close to each other, but they're not the exact same. That's why sometimes one value better represents data than the other. Now if we find the mode, that's the one that appears the most often. When we look through, I see 2 3/10 comes up twice, and the rest of them only appear once. So 2 3/10 is going to be that mode value because it occurs the most often. And then we need to find the range, which isn't a measure of central tendency, but it does measure how far our data spreads. So again, it's easiest when it's in order from least to greatest, and we subtract 4 3/10 minus 2 3/10. That cancels. And so our range value is 2. Let's practice identifying some modes. In this first problem, we want to know how many there are, and if there are any, we want to know how many of each. Sometimes there's more than just one mode, and again, the mode is the number that appears the most often. So when we look through, I see $1.50, I see one $2 value, I see one $2 and $2.25, one $2.40, one $3.50, and one $4. There's only one of each. dollar amount. So in this case, there is no mode because none of them appear more often than any of the others. If we look at B, we see that there's only 1, 2. It's, again, easiest when it's in order from least to greatest. Can't be the 2, 3, 6. The 8 appears 2 times. The 10's just once. 11, 12, both just once. 14 appears twice. So then in this case, because there's 2 of the 8s and 2 14s, one of them isn't appearing more than the other. So in this case, we have 2 modes. And the modes are 8 and 14. If we would have had another 14, then 14 would have been the mode because there would be 3 of them. But in this case, there are 2 of each, so we have 2 modes. The nice thing about modes is it doesn't have to be numbers that we're finding the mode for. It can be items instead. Again, it's nice when it's all organized by different item. We have 2 grapes, 1 banana, 1 nectarine, 1, 2, 3 strawberries, 1 orange, and 1 watermelon. We want to know which one appears the most often. It's not going to be any where only 1 appears. It's not going to be 2 because we have 3 strawberries. So in this case, we have 1 mode, and that mode is strawberry. Let's do one more mode. Looking at A. Again, it's always the easiest when they're in order in grouping pairs. So if we put them in order from least to greatest, we have 7, 7, 8, 8, 9, 11, 11, and then 13. So from here, we see that there are 2 7s, 2 8s, and 2 11s. All of them appear the same number of times. There's only 1 of the 9 and 13, so it can't be that. So in this case, we have 3 modes. And the modes are 7, 8, and 11. Sometimes when we look at a set of data, we have a number or an item that doesn't really fit with the rest. We call that the outlier. So it's typically a number that doesn't really go with the rest of our data or doesn't fit. So again, an outlier is a number that doesn't really fit with the rest of the data, maybe because it's way lower or it's way higher than the rest of the numbers. And it's going to affect all of our central tendencies because of that. So let's look at this one. If we want to find an outlier, we want to look through and see, well, where are most of our numbers ranging? And a lot of them are around the 10 to 15 range. And then we have this number 31. It's much higher than the rest. So in this case, our outlier is going to be the number 31. And it says to tell how it affects the mean. So in this case, we need to find our mean both before the outlier and without the outlier. So let's say our mean with the outlier and the mean without the outlier. So when we find the mean of this data, we want to add up all the values very, very carefully. 9 plus 10 plus 12 plus 13 plus 8 plus 9 plus 31. We're including the outlier this time, plus 9. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8, which is correct. And we get a total of 101. And now we have to divide by 8 because we have 8 numbers. So when we divide by 8, we get 12 and 625 thousandths. That is our mean with the outlier. Now let's find it without. So again, we're going to add up all the numbers, but we're not going to include this 31. 9 plus 10 plus 12 plus 13 plus 8 plus 9 and plus 9 again. Notice this time We got a different sum, and we didn't add up 8 numbers anymore. We didn't include the 31, so now there's only 7 numbers. So now we're going to divide by 7 instead. So not only is our total different, but the number we divide by, the number of numbers we added, is also different. So when we divide that by 7, we get 10 for our mean. So in this case, we want to know, how did the outlier affect the mean? Well, when we had the outlier in there, it increased the mean. And we want to be really specific, so we want to say by how much. And in this case, it increased the mean, and we're going to subtract. Including the mean minus without the mean. And so our outlier increased the mean by 2 625 thousandths. And that would be our final answer. We found the outlier. Our outlier was 31. And then we find both of our means to figure out how it really impacted that mean. Let's try that one more time. Again, we want to find the outlier. So we see a 1, a number in the teen, almost 20. So all of these numbers are numbers in the teens. And then we have the number 1. So in this case, our outlier is 1. So now we want to find the mean with the outlier. So we're going to add them all up, and we say 1 plus 17.5 plus 18 plus 19.5 plus 16 plus 17.5. We want to double check that we have the correct number of numbers, 1, 2, 3, 4, 5, 6, and I typed in 1, 2, 3, 4, 5, 6, so that is correct. For a total of 89.5, and because there are 6 numbers we used this time, we're going to divide by 6, giving us 14, and we'll round that, so 9, 1, and then 6 repeats, so we'll write that for now. And now we want to find the mean without that value. We're not including one of the numbers, so we're not going to use 6 anymore, and we're not going to add that 1. So this time, without that 1, our total is going to be 88.5. And we only added up 1, 2, 3, 4, 5 numbers, so we're going to divide it by 5 instead. So 88.5 divided by 5, and this time we get 17 7/10. So now we notice, let's make some observations. Our outlier is much lower than the rest of our numbers, whereas before our outlier was much higher. When it was much higher, it increased the mean. So this time we can make that educated guess that it's going to decrease the mean, but let's see. Look at the numbers. With the mean, it was about 15, and without the mean, it was 17. So when we included it, it decreased our mean because this number is smaller. And we want to say by how much, so we'll say 17 7/10 minus about 14 9/10, we'll say. And we'll say by about 2 8/10, because that's the difference between the two. So those 2 starred pieces would be our answer. The final part of this lesson is we have to be able to look at each measure of central tendency and determine which one is actually describing the data better than the others. So to do that, we have to find all 3 of them, which is already done for us. We have the data here talking about employees' hourly wage. I'll zoom in here so that you can see it a little bit more. We're looking at employees' hourly wages. When we look at them, we have a few at $5.50, a $6, $6.20, $6.30, $8, and $17. So when we find all three of them, the mode comes in at $5.50. That is the one that appears the most. The mean, when we add them all up and divide by how many there are, we get $7.50. And the median is that middle one. When we put them in order from least to greatest, that's the middle value. So we want to determine which one describes our data the most. If we look at our data, the first one that we can probably rule out because it's farther away from the others is our mean. And we can also rule that out because when we find the mean, it's taking into consideration of that outlier. And we have the outlier right here. That has a pull on the mean, whereas it doesn't affect the other two as much. So when we say the mean, it's probably the least reliable. Or it represents it the least because it's affected by that outlier. Then when we look at the other two, the mode is just the one that appears the most. When we look at our remaining data, our mode is the smallest number that we have. So it's describing the smaller end of our data, not necessarily taking into account that we have someone getting paid $8 and we also have someone getting paid $17. So in this case, our mode also isn't the greatest measure because it's only describing the low end. So this one also isn't describing the situation the best because it should be in the center of the data, but in this case it's the least. So we wouldn't want the mode either, we wouldn't want the mean. When we look at the median, it's always going to be in the middle, no matter how far it's spread, and in this case, the median is $6.10. That's not the lowest, it's also not the highest. It's kind of right in the center of our data. So in this case, it's not affected by the outlier. And it's also not just at one end of our data. It's not the least. It's not the greatest. It's also the center value of our central tendencies. So in this case, the median is the best one to describe our data. It's in the center of all of our central tendencies, and it's not affected by the outlier, and it's in the middle of our data. So we would say that the median describes our data the best. If we want to identify the best measure, sometimes it's easier than others. In example A, we want to determine which one measures it the best. We're talking about favorite movies of students in the 8th grade. So students, if we were giving this to students, their answers would be different movies. Well, the titles of the movies aren't number values. And if they're not numbers, then we can't use the median or that middle value. And we also can't add them all up and divide by how many there are, so we can't find the mean. So in this case, the mode is the only one that works because it's non-numerical. When we're looking at the daily high temperatures during a week in July, this time they are going to be numbers, so it could be any of them. And we want to know, what is that central tendency? Well, in July, temperature can fluctuate, and it's going to be super hot near the end of July. So we could take in mind, well, depending on how many really, really hot days there are, that could have an effect. Maybe there's one day in July that is really, really cold in comparison to the rest. So I would say the mean in this case may not be the best because there could be an outlier. We could also say that maybe at the end of the month there are a lot of hot days, and that could only describe the very end of the month. So that's not taking into account all of the days. So again, for this one, I would say that the median describes our data the best because it takes into account the really hot days, really cold days, and all of those in between. Again, the explanation for this is super, super, super important.